Welcome to the second part of the image processing and image analysis workshop. Now we start with a fresh geodict to pick everyone up, which might have got lost during the first part. So just double click geodict and wait until it starts. The license will expire in a week, but that's okay. Just click OK. And then here you see I'm still in the import GeoVol module. If this doesn't start automatically for you, just go over here to import GeoVol. And then we will reload the file that we just saved. You can either do this if you saved it yourself by double clicking down here on the file. It should appear there. And otherwise, if it doesn't appear there, or if you didn't do the first part, just go to import, click on browse, and then go one folder up into the workshop IPI folder, select the results M2M folder, and select the file here, cathode NMC cropped from the MathoMarket results. So everything is in there. Just click open, and then you get into the geometry import dialog. Since this is now a geodict raw file which we saved, all the data is automatically entered, so it knows information about the header size and the voxel length. Therefore you only need to click on image processing to load the file into the image processing dialog. Now we want to start with the image processing, and first we want to get rid of the noise here in our image. You can here see in the segmentation preview that the grains in here don't look really good. There is a lot of small noise in there, and for this we want to filter the image, and we want to use the non-local means filter, which is a pretty good filter to start with. For this we go here over to the image processing tree and go down to the image filters. And the first filter we will see is the non-local means filter. We want to use that one, but you might not directly know which parameters to enter, and therefore we will use the preview to try out some parameters and select the right ones, or the ones that we think are right for our structure. For this, click on the preview button, and then you get in the preview window. Currently you don't see anything because we didn't create a preview yet in here. Then what you can select here is the gray value image of your data. We will do that later, and the size. And down here you can select the parameters for your filter that you want to vary. We will start with the patch radius. That's the first parameter here. So start with the patch radius. And we want to start with a value of 1, which is the smallest one, and go until 3. The other ones we keep at default the window radius, and we decrease the strength to 0.4, since often 0.5 is a bit strong. Then click on Create Update Preview, and you see the very small previews up here. We can increase the zoom factor to see a bit more, and well, it's still quite dark, and that's because the gray value range is not selected properly. And for this we will select here the range which is also selected in the image processing dialog. So go over here, it's around 11,000. You just can enter 11,000 in here, hit enter, and then the visualization is updated, and you can see well, the result of the preview here. This is the original, where we can see that it's quite noisy, and here are the results for patch radius of 1, 2, and 3. As you might probably see, the difference is not that large, so maybe this here is a bit sharper. Well, might be, but the main point is the difference is not very large, and the computation takes much longer for a larger patch radius, and therefore since the difference is not very large, we stay with the patch radius of 1. So keep that here, and then we will vary the next parameter. So we go over to the window radius, keep the patch radius 1 here, and for the window radius we will also choose values from 2 to 4 to check this out here. Keep the rest as it is and click again create update preview, and now you see the results of the window radius, where well, the original is still noisy, that's clear, and here you see that the image for the window radius of 2 is maybe a bit noisier than the others, but the others start very soon to get blurry. So you see the borders of the grains look better here than they look over here, and much better than they look over here, and therefore we also stay with the value of 2 here. And now we change it here over to the strength value, and we want to vary the strength value from 0.1 well to 0.5. Keep it here, and keep the threshold step at 0.1. Click again on create update preview, then it runs through, and now you can compare the different results for strength, and here you can see that with a smaller value it's noisier, and it gets less noisy but a bit more blurry with higher values, and I think here the value for 0.4 looks quite good. Just to see that everything gets more blurry for higher values, we changed the last value here to 0.8 or even to 1.0. Click again on create update preview, and then you can see that everything gets softer back here. So we just stay with the value of 0.4. To select a combination of values here, you can click on the image to select it. If you click close here, the values for the filter get automatically updated. These are the values that we selected, and to apply the filter you only need to click the apply button below here. Depending on your computer, this might take some time. The filter runs on the GPU if you have a good GPU in your computer. If you don't have a fast GPU, it will run on the CPU, and it will take much longer. After the filter has finished, you can directly see that the segmentation looks a lot better, so you don't have the noise in there anymore, and the grains become separated quite nicely. You can also see below here in the histogram that the two peaks here are quite nicely separated. That's also often an effect of the NLM filter, that it helps to separate these peaks nicely. We can also change the gray value range to see a bit better down here. So we see the histogram really starts only at a value of 4000. So enter 4000 up here and update it, so we can see the histogram better here. Now that the filter is applied, we want to do the segmentation on our structure, and for this we change from the image processing options here to the segmentation and labeling options. And well, since this looks already quite nice, we want to use a quite simple segmentation option, and therefore we go here under the global thresholding options under the image segmentation option. Open that one, and I open this one a bit more here, and there you can select different methods. So first we want to keep the segmentation mode here for single threshold, because we have two materials, so we only need one threshold between the two materials. And the default method which is selected here is the Otsu method, which computes an automatic threshold based on the histogram of the data, and this works often very well. And already here it looks quite nice directly, but you can also change this to other options. For example, you can select a manual threshold or a k-means threshold. For example, I just show you the manual threshold, the values that they can enter here. So select that one, and then you can change the threshold by yourself. So you can enter other values in here. So for example, we can put in a 10,000 in here and there, and select what happens. So that's too high, so the whole structure just gets assigned to the pore material. But well, if you pull it down, everything gets segmented to the solid material, and something in between where you see that the value is now smaller than the Otsu value that was computed, but now all the grains also start to connect. So in this case, the Otsu result looked already quite nice, so we switch back to the Otsu method. So click here on Otsu and wait until it updates. I think it looks quite nice. The final thing we have to do before we want to do the segmentation is select the materials in our structure. So you can directly select which materials get assigned to the different phases in your structure, and we keep the material ID 0 as pore, which just means, well, there's nothing in there in this case here. And for the material 2 with the ID 1, we want to select NMC, which is the material here, and you get into the material selector by clicking here on the material, and then we scroll down to NMC 333, select that one, click OK, and then it should get updated here. So then you see the NMC material here, and we're ready to go. And then you can just click on create segmentation, and the segmentation is created. Now segmentation is finished. You get a result file from the image processing, where you can see that, for example, we use the Otsu method, the threshold value is shown. We see that we use the NLM filter, and you also get some information about the structure. So in the result file, that you see here, all the information is contained that you need to reproduce the same result with the same structure. But now we don't need a result file anymore. We can close this, and we can also close the image processing dialog, either with the X up here or with the close dialog option down here. Now we're back in the main user interface of Geodict, and here you can see the structure and the gray value image in the 2D view. So the structure is now displayed in red, because red is selected for the material ID 1, and here what you can see in gray is the gray value image. You can check this out by, for example, disabling the structure or the visibility of the structure up here on the structure tab. Just click on the checkbox for structure to disable it, and you only see the gray value image. You can also disable the volume field, then you only see the background. You can then re-enable the structure and compare both. You can also slice through it here to compare the segmentation with the gray value image. Now we want to have another look in the 3D view, so change from 2D to 3D up here, and then you can also see here the segmentation or the segmented structure in red and the gray value image. you can switch up here to the volume field tab and clip in the volume field to compare the segmentation with the volume field. If for some reason you're not happy with the segmentation, it's quite easy to redo the segmentation in the image processing dialog. And for this, you can go over here in the status section on the gray value image, right click on gray value image and select then open an image processing dialog. And then it just takes a moment and the gray value image is reloaded in the image processing dialog, and you can redo the thresholding. In our case, that's not really necessary because we're happy with the segmentation, and therefore we can just close this here. And since we also don't need the gray value image anymore, we can directly discard the image. So we not only close the dialog, but we discard the image by clicking discard image down here at the bottom. Yes, we want to cancel since we already did the image processing. So and we were okay with the gray value image to be lost here because we don't need it anymore. So just click yes. Now we want to analyze the grains in our structure. And for this, we will use the module grain find, which you can find up here under analyze and then grain find. Select it by clicking. And then the grain find module is opened below here in the module section. And we will use the identify grains option. This is directly correctly selected, and click on the edit button to edit the parameters. First, we want to change the result file name to cathode NMC identify grains. That's fine here, so that we know it's about the cathode here. And in the rest, we don't need to change much here under the grain segmentation tab, because using the current structure is fine. We want to analyze the structure. You can keep the minimal grain diameter to the default value of 2. In general, we recommend to keep the default value here because it leads to good results in nearly all cases that we know of. And only if the results with the default value are not good and you have further information about the grain diameters in your structure, we recommend to change it. So just keep the default here. We also keep the option to reconnect fragmented grains here. And we will also keep the option to remove grain fragments at the domain boundary checked to improve the statistics if you, for example, want to compute the grain diameters. Because if you cut off grains at the boundary, it's clear that the diameters of these grains are wrong because there are no half grains in the structure in reality. Now switch to the output options tab. And here we also check the option to save the grain size distribution as a GSD file because we want to have a look at the grain sizes in the structure. So click OK. And then click Run to start the analysis. So now the computation is finished. In my case, the result viewer directly starts here at full screen. Usually, if it starts smaller for you, you can just maximize it. And here in the identify grains result, you really get a lot of information about the grains in your structure. For example, directly information about the number of computed grains and a lot of statistics about the grain diameters and so on. but we want something to see, so therefore we switch to the grain visualization tab up here and select the grain segmentation result here and load the grains as index image. So click here on load G32. Keep that checked and click OK. And now it asks if we either want to see the structure or see the volume field that we loaded. We want to see the volume field, so we click yes at the question if the structure should be set to invisible. Now we minimize the result viewer and we can directly see the segmented grains in here. So we see that the grains in the structure are nicely separated. You can zoom in here and see all the separated grains in here. Let's switch back to the result viewer and load up the grain size distribution, which we also saved. That's the second entry here. So click on load.gsd. This file is now loaded instead of the grain index image. And at first we only see a blue box here. That's because the grain size distribution is showed in all the materials, also where no materials are, or where the poor material is. And well, it just starts at 0. Therefore, we go over to the volume field tab and go to the checkbox visible on material IDs and uncheck the ID 0 for poor. Click again in the image here, and then you see that the volume field is no longer shown where the poor material is. You also see some blue grains here at the boundary, and that's because we selected the option to remove the grains at bound and to remove the grains at the domain boundary, and therefore these are half grains which are not analyzed, and therefore the diameter of the 0 is shown here. You can change that by changing here the slider or the threshold slider for the equivalent diameter. So click on that and pull it up a bit, and now you see only the really analyzed grains. And if you hold the mouse over one of the grains, you can also directly see the equivalent diameter. Like for example, here we see a diameter of around 16 microns, and here for the lighter blue ones around 4 microns. Let's switch back to the result viewer, where we can also see some statistics about the grain diameters. If you click up here on the results tab, and then instead of report on the plots tabs, you get a lot of plots here. So these are clearly too many to explain here. But we want to have a look at the diameters, and just click on that, and then you directly get the histogram of the grain diameters in your structure. You see there's one main peak at around 8 microns, or here another at around 10, and another peak at around 13. That's it about the grain analysis on the structure. I think we go into another break now, which will take around 10 minutes, and after this we will start new with another structure.